Chapter 1, the modern periodic table. In modern periodic table, all the elements are arranged in ascending order of their atomic numbers. Following are the essential features of the periodic table. Groups and periods. Elements with similar properties are placed in vertical column called groups. There are 8 groups which are usually numbered by Roman numerals 1 to 8. Each group is divided into subgroups. Two subgroups designated as A and B subgroup. The subgroup containing the representative of normal elements are labeled as A subgroups, whereas B subgroup contains less typical element called transition element and are arranged in the center of the periodic table. The horizontal rows of the periodic table are called periods. The essential features of the periods are as follows. There are 7 periods in the periodic table, 1 to 7. The period 1 contains only 2 elements, hydrogen and helium. The period 2 and 3 contain elements each and are called short period. All the elements in these periods are representative elements and belong to a subgroup. In these periods, every 8 element resembles in property with the first element, as lithium and beryllium in the second period resemble in most their properties with sodium and magnesium in the third period respectively. Similarly, boron and aluminium both show oxidation state of +3. Fluorine in second period has cross resemblance with chlorine of third period. The period 4 and 5 are called long periods. Each period consists of 18 elements. Out of these 8 are representative elements belong to a subgroup similar to second and third periods, whereas the other 10 elements placed in the center of the table belong to B subgroup are known as transition elements. In these periods, the repetition of properties among the elements occur after 18 elements. After potassium 19, the next element with similar properties is rubidium. The period 6 is also a long period which contains 32 elements, in this period, there are 8 representative elements, 10 transition elements, and a new set of 14 elements called lanthanides. As they start after, lanthanides have remarkably similar properties and are usually shown separately at the bottom of the periodic table. The period is incomplete. 7 is incomplete so far. It contains only 2 normal elements, praseodymium and rubidium, 10 transition elements and 14 inner transition elements. The inner transition elements of this period are called actinides, as they follow actinium, and the actinides are also known as the bottom of the periodic table under the lanthanide. Due to their scarcity, the inner transition elements are also called rare earth elements. Some more families in the periodic table. While studying about period, we have noticed that certain rows of elements with similar properties have assigned common names such as transition element, lanthanides, actinides, or rare earth elements. Similarly, due to their peculiar characteristics, some typical elements belonging to a subgroup A have also been assigned family names. For example, elements of group first A are called alkali metal because of their property to form strong alkali with water. Similarly, due to their presence in earth crust and alkaline character, the element of a periodic table is halogen family. The halogen family is given the element of 7th A due to their salt forming property, as the gases of the group 8th A are least reactive. They are called noble gases. These family names are useful for quick recognition of an element in the periodic table. Block in the periodic table. Elements in the periodic table can also be classified into 4 blocks. This classification based upon the valence orbital of the element involved in chemical bonding. According to this classification, elements of first A and second A subgroups are called S-blocks elements because of their valence electron available in S orbital. The elements of third A and fourth A subgroups are known as p block elements. Their valence electrons are present in p orbital. Similarly, transition element electrons are in d orbital are responsible for actinides valence electrons are present in f orbital. Hence, these all elements are called f block elements. This classification is quite useful in understanding the chemistry of elements and predicting their specially concept of valency of oxidation.